Thanks for introduction. I'm very happy to present our recent research about the AI-ECG, and I will talk about this topic from the dataset, the method, the wearable devices, and the clinical applications. So what can AI-ECG do? We have just listened the previous speaker, and we have learned a lot. And this is from my side, and the classic task of AI-ECG is to detect the atrial fibrillation from short single-lead ECG. And actually, this is my start of the research because I'm a guy from the AI research area. I got my PhD from the Department of Artificial Intelligence, but actually participate in this challenge and then going to the medical area. So in this challenge, the dataset is given by the Alive Core. They create a single lead mobile to collect the single lead ECG called the cardiac, and they release around 8,000 single lead ECG dataset and collaborate with the PhysioNet platform and have a computing cardiology challenge. And in this challenge, I was at that time I was a PhD student, and I read some engineering papers and develop a convolutional neural network and combine these two together. And very luckily, we have got the first place of this challenge, and this is the start of my research. And so this task is not interesting at all because it's a very classic task. But recently, we have monitored a lot of the work that we can expand the ability of the ECG into many kind of systematic disease. So in the AI era, more and more diseases are associated with ECG. So the left part, the second paper is like the most hot paper recently. They have used the AI to detect the structural heart disease from the ECG and got published in the Nature journal, and many people are very interested in this. And also, this paper is also very interesting because they actually develop and deploy an AI ECG model into the hospital, and they have a pragmatic randomized clinical trial to very seriously evaluate the effectiveness of the AI ECG model. So the AI has actually made the ECG great again in this time. So from my topic, I will introduce in the four parts. So the first one is the data set. So ECG data is very complex. It's quite different from the image data and the text data. It's a kind of the time series data. So the time series data has some unique features, like they have a multi-scale view, and we should analyze it from the temporal domain as well as the frequency domain. And also, if we have some halter ECG, then the data set is very long compared to the snapshot of the image. And also, it is pseudo periodic, and different people have different personalized ECG data, and for one people, they will present different morphology of the ECG in a different time. So the complexity of the ECG data bring us that we cannot use the current model trained on the ImageNet, or we use the GPT-4 to interpret the ECG directly. They will not understand this kind of data. So this is why I'm in the AI area and develop many of the novel deep neural network to analyze ECG data more accurately and more efficiently. So recently we proposed a new terminal, like we call this is the ECG multi-modalities, because the ECG data is not only the time series data. Also, we know the time series data has some like short-term, long-term, and single lead, 12 lead. They also have varied a lot. And also recently we have many like requirement, like they only have the paper-based ECG image data, but they also want to deploy an AI model to analyze this kind of data. So the ECG image data has come into the ECG area. And also we have some descriptions of the ECG data, like the annotations from the doctor and the wave measurement of the ECG. And also we have some correlated diagnosis codes, and also with some other associated reports, like from the echo or from the CMR. So we have want to combine this multimodality data associated with ECG together to build a large model to analyze ECG. So to achieve this, we have some try this research is when I was a postdoc in the Harvard Medical School. We have started this project, and recently we have released this database. It's called the Harvard Emory ECG database. We collect over 10 million ECG recordings from around 2 million unique patients, and all of this data set is associated with multi-ethnicity and multi-age, and also the multi-disease. Yes, it's very cool because every ECG has associated SED diagnosis from the entire hospital, so we can imagine a lot using this data set. And also we have released the world's first multimodal ECG dataset called the MITI. We deployed this from another open source dataset called the Mimic ECG dataset, but we plot the ECG image, and also we calculate the ECG parameters and the ECG report. And also we have built another ECG large model called the GEM. This paper just got published in the New York's. It's a top tier conference in the AI area, and we generate the description in the very detailed description from the large language model. So we combine this together and release the dataset. It has been deployed in the Zenodo, and the paper is got under review as the Nature Scientific Data. So for the method, this is a very simple timeline of the development of the AI technology. In the beginning, we are develop some traditional pattern recognition algorithms to extract meaningful features to discriminate some disease. And after the 2017, we have some deep learning algorithms. So the focus is how we can get a state-of-the-art AI-ECG backbone network, and also we have to integrate the deep learning method with the traditional pattern recognition algorithms. And also after 2021, the self-supervised learning algorithm is the hot topic in the AI area. So we want to learn the intrinsic representations from the ECG data structure, but instead of the labeled dataset using the self-supervised way, because we know the labeled data is very very hard to acquire. So many of the ECG dataset is unlabeled, but we can also learn a good representations from it. And after the 2023, the generative method and the large language models is the research focus in the AI area. So from my side, we recently built the large, maybe the world's first or the largest ECG foundation model. We can cover multi-scenario clinical needs, like we have the detect the multi-system disease risk assessment, and also we can analyze the comorbidity and the prognosis of the patient outcome, and we have some non-invasive measurement of the lab test measures, and also we have some approximate measurement of the the LVEF indicator. And this work has been just published in the NEJM AI journal. If you're interested, you can read the paper in detail. So we test the model on the compare with the labels generated by the cardiologist, and we evaluate on around over 150 ECG diagnoses, and over 100 kind of the labels have an AUC greater than the 0.9, so it's very high performance. And also we evaluate the model on the single lead ECG and as well as the 12 lead ECG to detect the arrhythmia. And also we can estimate the heart age, the NT-proBNP, the LVEF, and the future risk of the CKD, and the future risk of the CHD. So it's very comprehensive. So the technology behind the ECG Founder, we have built a model called a deep learning architecture called the Net1D, and we also publish this code in the GitHub. So we design a unique convolutional neural network with the one-dimensional convolution layers to transfer the ability from the image to the signal. And this model has also been used in many other biosignals like the accelerometer and the PPG. And also the center paper is another NGM AI paper published by our group. We use the same architecture on the EEG data, and we can detect the epilepsy markers very precisely. The training strategy, we have to encounter some like the imbalance problem and also the positive and unlabeled problem. In a word, our model is very accurate. So if you want to use the ECG Founder, you can find the code in the GitHub and find the trained model. We have released the parameters of trained model in the Hugging Face. So there is already a research team from FY. They use the ECG Founder to do the post-training and to further improve the performance of the ECG model on their own task and on their own data set. So the future of ECG Founder, we have some recent interesting trial. This work is we try to generate the ECG data from the PPG data using the diffusion models. It's a very novel algorithm in the AI area. Like maybe you have been used this Sora. You can generate the video from text, and we generate ECG data from PPG data. So why we do this? So we know that the wearable devices can collect PPG data, but the doctors cannot interpret PPG data, even for the simplest AF detection. So we generate the PPG data from generate ECG data from PPG and ask the doctors to detect whether the patient has present AF or not. So the result is that if the doctor only interpret the PPG data, the F1 score of the AF detection is only around 0.77. But if we provide the generated ECG data, then the performance will increase to the 0.94. So it's very interesting try. And also we have another work to generate a 12-lead ECG from 3-lead ECG to detect the MI disease. Like we had tested the different origin of the MI on the original 12-lead and the generated 12-lead from the 3-lead. So you can see the original 12-lead has reached AOC of the 0.88, and the original 3-lead only have the AOC of the 0.82, but when we use the generated 12-lead, the performance will increase to 0.87, so it's increase of the original data. So we can treat this as the augmentation of the pool data set, like the 3-lead ECG, a pool data set with the AI to enhance the data set to be a rich data set, to be a 12-lead, so they can detect more from the pool data set with the help of the AI. So finally, we have another work to understand and generate ECG in one model. So we hope to deploy this model into some current commercial large language model, like the GPT or some others. So if we can try, so if we have already tried the commercial large language model to interpret the simplest ECG image or the ECG signals from the XML data, they will not understand the data at all. So we have to specifically design or train the large language model to understand this kind of data. So this is what we are trying to do. And finally, the wearable devices and the clinical applications. So to me, I'm very interested into the wearable devices. It's data pioneers to the current clinical data. Because in a hospital, the patient can only collect the clinical data in one spot in a discrete time. but we want to expand the health monitoring of the patient in the spatial domain and in the temporal domain. So we have to use the wearable devices out of the hospital to collect the continuous, dynamic, multidimensional, and multimodal health monitoring data. And the ECG is the core of these wearable devices. So recently the wearable devices and AI and some software has been the research hot topic. So this review is from the New England Journal of Medicine. They use the wearable devices with AI as a connection between the patient and the doctors. And yeah, to a time limit, I will not introduce the detail of the papers, but if you're interested, you can read the papers. And also this paper is just published from the MPGA Cardiovascular Health, and it's very comprehensive illustrations of the entire figure map of the AI wearable devices. So in my team, we also build an AI-ECG device, just like the live call, the cardiac, but it's more cheaper than that device because in China we cannot afford to buy that expensive device for ordinary people. So the software, the hardware, and algorithms are all designed by ourselves, and the cost is very low. So our goal is that anyone can collect their ECG without the help of medical staff in 2 minutes, and also they can interpret their ECG. So we deploy our large language model can understand ECG data in the WeChat mini program. So everyone has the WeChat, so they don't need to install their own app. It's very easy to get, and they can interpret the diagnosis results and get some like clinical advice or the exercise advice from the app, and they have been like a closed loop health management of the heart disease. So currently we have over 100,000 users, and we are also seeking for the collaborations with the hospitals. So we want to use this smart device to conduct clinical research. Like recently we have one collaborations with the Peking University First Hospital. We use the device to non-invasively measure the serum potassium of the people. Especially we do some randomized clinical research in the CKD patient, and this is a multi-center trial, and we have already finished the pilot study. We hope to report the results in the next year meeting if you are interested. The LC is over 77 on the external data set, so it's acceptable for the screening, at least the opportunistic screening. So the opportunistic screening is another idea of how we can get benefit from this AI device, because we cannot like bear the error made by the AI, but at least the AI can give us some out of the mind abilities, so we can deploy these AI models into some devices and do a real-world study to do the opportunistic screening. So this work is still ongoing, but we are very like interested in this work because we collect over 4 million single-lead ECG using our device from over 100,000 patients, and we opportunistically screening of the WPW syndrome. So we, if the AI, so this is a diagram of this research. If the AI raise an alert of the high risk of WPW, then the patient will ask the doctors to interpret their ECG data for the second time. And as an outcome, if the AI has raised a high risk, then the risk ratio of the no alert is around 210 times to the low risk groups. So finally, our goal is to make the ECG great again with the enhance of the AI algorithms. yeah, so this is my talk, and thanks to all the collaborators. Thank you.